Hello, my students, and welcome to this episode. In this session, we are going to talk about basic definitions and concepts on the cycle. So, what is the definition of the cycle? The cycle is a closed curve. All points on it, at a fixed distance from a fixed point. The fixed distance is called the radius, and the fixed point is called the center of the circle. Okay, so here we have a circle M. The point A lies on the circle. And pay attention to the difference between the circle and the surface of the circle. What is the difference between them? The closed curve is the circle. The closed curve is the circle. And the surface of the circle contains the closed curve and all points inside this circle. So here, if I'm talking about the point A, for instance, the point A belongs to the circle. Okay. What about the point C? The point C doesn't belong to the circle. What about the point B? The point B also doesn't belong to the circle. When it comes to the surface of the circle, and if I have a point like this point here, the point C, and here the center M, the point C doesn't belong to the circle, but the point C belongs to the surface of the circle. So the shaded area here in the second figure represents the surface of the circle. Once again, what is the circle? The circle is the closed curve. Okay, all points on this curve belongs to the circle, and at the moment belongs to the surface of the circle. When it comes to a point inside the circle, like the point C, the point C doesn't belong to the circle, but the point C belongs to the surface of the circle. What is the definition of the radius? The radius is that line segment that joins between the center of the circle and any point on the circle. So in this circle here, you will find MA as a radius, so MA equals R. And what about MB? We couldn't say that MB is radius, but MB is that line segment, and its length is more than the radius. What about MC? MC is not radius, and the length of MC is less than the radius. If we looked at this circle, can you tell me where are all radii in this circle? So here we have MX. MX is radius, and also ME is radius, and MF is radius. Okay. What about AB? AB is not radius in the circle. AB is called chord in the circle. And also CD is not radius, but CD is a chord in the circle. So what is the definition of the chord? The chord is a line segment that joins between any 2 points on the circle, like AB is a chord, the line segment AB is a chord, and the line segment CD is a chord. Okay. What about EF? Also, EF is a chord. But if you focus on EF, you will find EF is passing through the center of the circle. Okay. If you find a chord passing through the center of the circle, so we can call it diameter. So what is the diameter? The diameter is that chord, okay, that passes through the center of the circle. And the diameter is the longest chord in the circle, is the longest chord in the circle, okay? So once again, what is the definition of the diameter? Simply, the diameter is that chord that passes through the center of the circle. The diameter is the chord that passes through the center of the circle. And the diameter is the longest chord in the circle. The length of the diameter, D, equals 2R, 2 multiplied by the radius. As you see here, EF is a diameter. And the length of EF equals 2 multiplied by the radius of the circle, because ME is a radius and MF is a radius, okay? So EF is a diameter, and the diameter is the longest chord, and the length of the diameter equals 2 multiplied by the length of the radius. Here in this circle, we have MA, and MA equals 7 centimeters, and MA represents the center of the circle. I want to find the circumference of the circle and the area of the circle. The circumference equals 2 pi r. It's 2 multiplied by pi. Pi is given as 22/7 multiplied by the radius, which is 7. Okay. Cancel 7 and 7. You will end up with 44 centimeters. What about the area of the circle? The area equals pi r squared. Pi is given as 22/7 multiplied by 7 raised to the power of 2. The radius is 7. So here, cancel 7 and the power of 2. It will be 154 centimeters squared. That's it. In this circle, we have an angle A. The size of angle A is 25. I want to get the size of angle M. We have here MA. MA is a radius, and MB is a radius. So this triangle here is an isosceles triangle because we have MB and MA, and they are equal in length. So this triangle is an isosceles triangle. So the measure of angle B is 25 also. Okay. So now we can find the size of angle M. The size of angle M, measure of angle M, equals 180 minus 25 plus 25, which will be 180 minus 50. So the size of angle M is going to be 130 degrees. How many lines of symmetry for the circle? Any circle has an infinite number of lines of symmetry, and any straight line passing through the center of the circle, consider a line of symmetry. So here we have a straight line, and this straight line is passing through the center of the circle. So this straight line is called an axis of symmetry or line of symmetry for the circle. And the circle has an infinite number of lines of symmetry. So here we can draw an axis of symmetry here, like the blue line, and also we can draw another axis of symmetry. So how many lines of symmetry in the circle? Any circle has an infinite number of axes of symmetry. Now we are going to study the position of a line with respect to the circle. The line L here in the first figure touches the circle, okay, at the point A. The straight line L here is called the tangent to the circle. And this tangent touches the circle at one point. So the straight line L intersects the circle M at the point A. And when it comes to the straight line L intersection the surface of the circle M, so the line L intersects the surface of the circle M at the point A. Okay, so once again, the straight line L here in this case is called a tangent to the circle, a tangent to the circle M. And any tangent to any circle is perpendicular to the radius. The tangent, very, very important. The tangent, any tangent, is perpendicular to the radius. Okay, the tangent is perpendicular to the radius. And this point A here is called point of tangency. Point of tangency. Okay, so once again, the tangent is perpendicular to the radius from the point of tangency. The point A is called the point of tangency, and the straight line L is perpendicular to the radius. The radius is MA. The next one, if the straight line cuts the circle at 2 points here, so the straight line here is not a tangent, it's called a secant. Okay, and the straight line L intersection the circle M at 2 points, the point A and the point B. If I asked you about the straight line L intersection the surface of the circle M, if I asked you about the intersection between the straight line L and the surface of the circle M, the surface of the circle means all shaded part here. So as you see here, the straight line L intersects the surface of the circle at line segment AB. So the straight line L intersection the surface of the circle M at the line segment AB. And if the straight line was outside the circle, so the straight line L in this case intersection the circle M phi, and the straight line L intersection the surface of the circle M phi. There is no points here. In this question here, AB is a chord, and the straight line L passes through the center of the circle. What is the required? The required is to prove that MD here is perpendicular to the chord AB. So we are going to construct two lines. We are going to draw two lines. Draw MB and draw MA. Okay. So here we have MB. MB is radius in the circle, and MA is radius in the circle. So they are equal. And MD here is a common side. MD is a common side between the two triangles. And the point D is the midpoint of AB. So what is the given? The given in this figure here, we have MB is equal to MA. Both of them are two radii in the circle. And D is the midpoint. D is the midpoint D is given that as a midpoint of AB. And I want to prove that MD is perpendicular to AB. We have here in two triangles, we have two radii. MB is radius and MA is radius. And we have MD. MD is a common side between the two triangles, is a common side in the two triangles here. And we have the point D as a midpoint between midpoint of AB. So MD is equal to DA. So here we have two congruent triangles because the three sides are equal. So we have MB equals MA, and also we have MD. MD is a common side, and BD equals DA. So the two triangles here are congruent. And from that, we can deduce if the two triangles are congruent. So this angle here is equal to this angle. So the measure of the angle, from that, we can deduce that the measure of the angle MDB is equal to the measure of the angle MDA. And both of them equals 180. When adding the two angles together, we will get 180. And because they are equal, so we'll divide 180 by 2, you will get 90. So we reach to an important conclusion, which is the straight lines which is drawn, okay, which is drawn passing through the center of the circle, the straight line passing through the center of the circle, and the midpoint of any chord, is perpendicular to this chord, Once again, what I said that the straight line passing through the center of the circle, and bisects any chord, will be perpendicular to this chord. Here in the circle M, we have AB. AB is a chord, and we have a straight line, and this straight line is drawn perpendicular to this chord. I want to prove that D is the midpoint of AB. I want to prove that AD equals DB. So we are going to construct two line segments here. So I have drawn MA and MB. And the two triangles here are congruent. Do you know why? Because MA is radius and MB is radius. And we have MD here is a common side. So we have two equal radii. And the radius here is a hypotenuse in the triangle. So MA is a hypotenuse in this triangle, and also MB is a hypotenuse in this triangle. So we have here R, this is right, this angle is right here in this triangle, and this angle is right. And we have a common side here, so this side here and this side in this triangle are the same, so it's a common side. And we have two equal radii here, and this radius is a hypotenuse in this triangle, and this radius is also hypotenuse in this triangle. So we have RHS. That leads to get two congruent triangles. And from congruency, we will deduce that AD is equal to DB. So here we have, in the two triangles, we have MA equals MB equals R. And MD is a common side. MD is a common side. And the measure of the angle MDB equals the measure of the angle MDA equals 90 degrees. So we have, again, we have two right triangles. We have two right angles, sorry, here in both of them. And we have two equal sides here because they are two radii in the circle. And we have a common side that leads to get two congruent triangles. And from congruency, we are going to use that BD equals DA. So D is the midpoint of AB. Here we have a circle, and I want to know the center of the circle. So in which place the center of the circle exists? How can we determine the center of the circle? So bring your ruler and draw a code here, like this code. And find the length of this code. Find the length of this code, okay? And from the midpoint of this code here, from the midpoint of this code here, draw a perpendicular. From the midpoint of this code, draw a perpendicular, okay? Again, I have drawn a code in the circle, and I determined the midpoint of this code here. Let's call it C. And from the point C, draw a perpendicular to this code. So we have here, we have a line, we have a straight line, and this straight line is perpendicular to the code. And at the moment, bisects it. And we have studied, if we have a straight line, the first color we have studied, if we have a straight line passing through the center, okay, and bisects any code, is going to be perpendicular to this code. And the second color we have, colors we have studied, the straight line, okay, which is bisects any code and passing through the center. If the straight line bisects any code and passing through the center is going to be perpendicular to the code. And if the straight line is drawn perpendicular to the code and passing through the center of the circle, is going to bisect this code here. Here we have a straight line. Here we have a straight line perpendicular to the code and bisects it. So this straight line must pass through the center of the circle. So here determine the 2 points on the circle. Let's call them XY here. So XY here is a diameter. XY here is a diameter. And why I said that XY is a diameter? Because this straight line bisected this code and perpendicular to it from the midpoint. By finding the length of XY, okay, then take the half of this length. And the half of XY is the radius. So this point here is the center of the circle. That's it. I hope you enjoyed this session. See you in the coming episodes. Goodbye.